Let's try this. We're going to try and build a systems model together. And so everybody should pull out their computer. And let me show you a little bit how this is going to work. We're going to take figure 4 from the pre-reading that you did. And I've shown it down here in tiny, but we'll be working from that. And from that, we're going to hopefully learn about some of these concepts that we've covered in class. And you'll also see how to build a model for yourself and how to run it and get some practice doing that, which should be valuable. So I'll just mention quickly the model and run through it. So there's very little text in the reading about it. It just basically says this: the volume of wood in the living forest, in the living trees in a forest, is a stalk. Its inflow is the growth of the trees. Its outflows are the natural deaths of trees and the harvest by loggers. The logging harvest flows into another stalk, perhaps an inventory of lumber at a mill. Wood flows out of the inventory stock as lumber sold to customers. So we want to capture that. We want to build that into a model. And by doing that, hopefully we'll capture some of these ideas of feedbacks and such. So here's the picture that goes along with that. And we're going to try and recreate that in Insight Maker. So to do this, this is a little bit maybe scary. And so we're going to have to keep on our toes a little bit. So what I would like you to do is let me know how you're doing as we progress through this. And so to do that, I've opened up a poll here where you can click in, and I'd like you to click in regularly, every minute or two. Just let me know how you're doing. And down here are the responses. A, yawn, where's the fast forward button? So, you need me to speed up, hit A. B, you're okay, just hit, that's fine. Let me know that you're on track and things are good. C is if, you're okay, but you're getting a little nervous. And D means, whoa, I'm falling far behind. I need you to slow down. E means, uh-oh. It means back up, I missed something. Now, I'm not going to respond and adjust to every individual, every student. So I'm going to be looking at trying to track the bulk of what's going on up here and stay with you guys there, which is why we have Kevin and Pranesh, who will be walking around, and in particular through rows 3 and 6. So hopefully they can reach all of you. And if you have a problem, you can ask them, just raise your hand and they'll come by and help you out. And if things go totally haywire and you're completely lost and you don't know, you just, whatever, go to Canvas. And on Canvas, you will find a link to the model that I'm working with at the time, and it will save every minute or so on my computer and get shared out to you guys. And so you can go from there, find that link, and then once you're on that page, you can clone that Insight to get your own copy that's all up to date. And then you can catch up quickly that way and keep working, okay? So we'll see how this goes. Okay, anything else I want to say about that? Talked about that. Okay, so to get started, I'd like you to go to insightmaker.com, make sure you're logged in, hit A when you've logged in. All right, the next step is to create a new Insight. So there's a button for that. Go ahead and do that. Hit A once you've done that. And the first thing that you're going to want to do when you start a new Insight is to save it. So there's a button to save your Insight. Go ahead and click that. And then it'll ask you for what the name of the model is and any details you want. For now, maybe you want to make it private, but there is an option to make it public as well. So go ahead and do that. I go ahead and save it, private or public, as you like. Okay, let's get started. So you're going to start with some bunch of stuff on the screen, which, sorry, I've already cleared off of mine. Let me show you what it looks like. So there's going to be a bunch of stuff like this on your screen, and you just want to click this button up here to clear that out. There's lots of useful information. You can look at it on your own time, but for now, we're just going to move forward. So clear the model, and you'll start fresh. Okay, so now we want to start building this model out. So the first thing, let's see what we want to add. Let's say we want to represent the forest. So the wood in living trees. What kind of element should that be? A stalk. Very good. Okay, so we can click here under Add Primitive and just add stalk. Bang, we've got a stalk. If you go over to the right here, you can change the name of your stalk. So let's call it exactly what it says in the model, wood in living tree. You can drag these elements around. Ooh, that's fun. You can do fancier things. You can change the shape, colors. You can replace the elements, the rectangle with the picture if you want. Do all sorts of pretty little stuff like that. But it doesn't change the underlying dynamics of what we're doing. Okay, does anybody remember the one thing you have to do with a stock? Perfect. We need an initial value. So, let's say we're talking about I don't know how big this is, but I don't know. How about 10,000 trees? Does that sound reasonable? Let's do that. So you can change here on the right. You can see the initial value, and I'm going to punch in 10,000 and then hit enter. On any element like this, you can also click the drop down, and that'll give you a box where you can enter more information, and it'll look something like this. In our case, we don't really need that. It's just a simple number we need to type in. Okay, let's run our model. This is exciting. Okay, to run a model, you press simulate. You've probably already done it. I was going to ask you, what do you think you're going to get? But you probably already saw this. So what you're seeing here is the model running out over time, and it's tracking the stocks that you've got in your model. In this case, it's just one. It's the wood and living trees, and it's just 10,000. I hope that makes sense. We haven't introduced any flows in or out, so it shouldn't be changing over time. Okay. So let's see, what do we want to add next? Let's change things a little bit. If we run this simulation, you can see it runs out for 20 years. And maybe if we're interested in a forest, we really want long-term to check whether it's going to sustain over a long term. So we could put in change it so maybe it's 100 years, but let's go really long term. Let's say we're interested in 1,000 years from now. We want to make sure the forest is still there in 1,000 years. Kevin, oh yeah, thanks. See what I can do. Okay, so you can change your settings here. And what we'll do is we'll change our simulation length and make it 1,000 years. We could change the units, but let's leave it as years. Okay, that's pretty easy, and you guys are with me. So let's speed it up a little bit. Next, I want to introduce a flow of tree growth. So to do that, watch this a little bit carefully. What I do is, when you hover over one of these elements, you can see that there's this little arrow in the center of it. If you click and drag that, you can create a flow. Exciting. Okay, so I've got a flow. I can name it again. Let's call it tree growth. Does anybody see anything weird about what I've got here? What's that? Yeah, it should be going in. Okay, so to fix that, you just make sure you highlight the arrow that you're interested in and you reverse the direction. Okay, and when you click that button, now it's a flow into that stock. So just to make sure we're all on the same page here, what do you think is going to happen if I run it now? Yeah, nothing, because I haven't specified a rate of flow. Right now, the flow rate is 0. So let's actually introduce some tree growth. Let's say we have 100 trees being born every year out of those 10,000. So I change my flow rate to 100. Don't forget to raise your hand if you're confused or lost. And don't forget to click in frequently to let me know how things are going. Okay, let's run this simulation and see how it goes. Well, it goes slowly. That's what I see. So you can change the speed of your simulation here. I'm going to make mine 10 times normal. Okay, so we're seeing the forest grow from 10,000 trees to 110,000 trees over the course of 1,000 years. Why? Real forests probably don't do that. What else is going on in a real forest that we haven't captured yet? Death. That's right. Yeah, okay, so we need to introduce some death. And so that's in the model here. You can see there are tree deaths. So we need another flow out of the wood and living trees. I'll just put it straight down to save space. And let's call it tree deaths. Okay, now I guess there's a question of how fast are the trees dying? What should we put in as a flow rate for tree deaths? 600. Okay, 600. So what do you think is going to happen here? Yeah. Yeah, the tool is just going to faithfully do what you tell it, even when things don't really make sense anymore. You see what we're getting here? We started with 10,000 trees, and then it quickly dropped to 0, and then we have thousands and thousands of negative trees, which doesn't make a lot of sense. Isha? Yeah, so there is an option for that. You can, if you click on the stock, you can choose whether to allow it to have negative values or not. I would not recommend changing that, because if you change that, you're trying to enforce a constraint on your model that isn't biological. There's a reason tree stocks don't go negative, and it's because they don't keep losing 600 trees a year forever. There's only a loss of trees when there are trees to be lost. So we need to make the death rate of trees depend on how many trees there are. So I would not make this negative. I think that's, I would not restrict it to being positive. I think that's too artificial. Instead, we can change our flow rate. And let me bring up the box, and we can see how we can change this thing. What we have available to us is the amount of wood in living trees, and that can be a variable we use to determine how fast we're losing trees. And maybe we're just losing a fraction of the trees every year. Maybe, I don't know, I don't know how long trees live. Let's say they live 200 years. So maybe every year we lose 1/200th of them. So then we could create a formula here, which is the wood in living trees divided by 200. Does that make sense? Let me just mention that it is possible to add units to all of these things by clicking this button. I would avoid that. I find it creates more problems than it helps. So maybe for now we should just work unitless. That's just an aside, don't worry about it. Okay, now that we've got that, let's hit apply and run your model. See what's gonna happen. You should see something like this. So what you should be seeing is that the stock of trees increases, but as it increases, the death rate increases. And because of that, it counteracts the rate of increase of the trees, the stock. And eventually they come into equilibrium. So the birth rate and the death rate match each other, and we have a steady population of trees. And that will be around 20,000 trees. Okay, so we've got tree growth, we've got wood in living trees, we've got tree deaths. We're just missing the logging / lumber side of the model. So let's add a new stock to capture the idea of there being a lumber inventory. So to create a new stock, please do that and see if you're right about how to do that. So create your own stock. And you should have done something like this: add primitive, add stock. And I'm gonna put mine there, doesn't really matter. Let's call this stock lumber inventory. We need a starting value. Let's say maybe 1,000 logs. It's arbitrary. Maybe if we were trying to model a particular situation, we'd actually go out and find out how many logs there are, how much lumber there is in that situation, and then model that. But this is all kind of made up, so we can just choose a number. Okay, so we've got a lumber inventory of 1,000. Let's run the model again. And now you see we have the trees again going up to 20,000. And we have another line here, this dark blue line, which is the lumber inventory, which is just a constant number, 1,000, because there's no flows in or out of it. So we need to add some flows. Let's start with sales. So do you remember how to create a flow? Please do so. You want a flow representing lumber sales. So probably yours will look something like this. Now, let's get a little bit more nuanced in our model here. Instead of a constant flow rate, let's have kind of a conditional flow rate. What we want is maybe there's demand for 100 logs a year, but if there aren't 100 logs left, then the demand is just for whatever there is, the full inventory. So to do that, I can't just say 100, because that means there will be a demand for 100 even if there aren't 100 logs left. So I need to introduce a little bit of programming, and we can find that here on the right. There's all sorts of things that'll help you out. And one of them is programming functions. We want an if then else. So go ahead and click on that, and you should see something like this pop up in your flow rate equation box. That was here, if then else, under programming functions. This is a little bit complicated. There's all sorts of things we need to fill in here. And the way it's set up right now is it says, okay, if there's a particular condition and we have to say what we want that condition to be, then we want a certain number to pop out, to be returned. And then it says else, if there's a different condition, then we want a different expression to be returned. And else, if neither of those are the case, then we want another expression to be returned. So this whole thing gets a little bit complicated. We can simplify it a little bit because there are only two cases that we're interested in. Either there are more than 100 logs available or there aren't. So we can eliminate one of these conditions. So I'm just going to delete all of this stuff here to make this a little bit simpler. So I've deleted it. So now we only test for one condition. And if that condition is false, then we're going to add a new thing to it. So what is the condition we're interested in? What was that? Yeah, if the lumber inventory is bigger than 100. How many sales do we want if the lumber inventory is bigger than 100? The demand was 100, so I'll just punch that in. But what if there aren't 100 logs available? Then how many should be sold? Yeah, because it won't matter. Because we could put it greater than or equal to, which would look like that, and it would give us the same thing as what I'm going to do here. So what do we put in this expression here? If there aren't 100 logs, how many do we sell? Jeff? Yeah, exactly. The lumber inventory itself, all of it. So if there's only 50 logs, then we sell 50 logs. Okay, so let's apply that and let's simulate our model and see how it goes. Go ahead and do that. So probably you'll see something like this, where that initial inventory of 1,000 logs drops off very quickly, and then we're left with 0 inventory. So we need some logging to replenish that stock. So I'm hearing a report that somebody's having trouble with Google Chrome, that there's insight makers. And are there other people using Chrome right now? And does it work okay? Okay, thanks. Okay, so let's add logging. So we need a flow from the wood in the living trees into the lumber inventory. So we can just drag it over. And you can see the lumber inventory has just turned green. That means those things just got linked up. Let's call this flow logging. Okay, so let's say we're trying to be sustainable. So we know there's a demand of 100 logs a year, and we don't want to harvest more than that. So maybe what we want to do is just match the amount of logging that we're doing to the sales. So whatever the sales are, that's how much logging we'll do. To do that, we need to introduce a link, because logging and sales are not directly connected to each other. So at the top here, we can switch from drawing arrows that are flows to instead drawing links. So click that, and now when we drag from lumber sales, we can drag a new arrow to logging, and it's a different kind of arrow. Now it's a link. We haven't said like how we're related yet. It just tells us that logging will depend on lumber sales. That's all it says. So let's determine how it should depend on logging sales. So if I click on the rate equation for logging, now I can see that here I have variables that the logging can access. It's the 2 stocks it's connected to and lumber sales, because we created this link. We want the logging rate to be exactly equal to the lumber sales, so we can just enter it right there.
Is there a way to tie it to here's lumber sales so that we know what the lumber sales are?
There are, yeah. You can add delays to your model, but let's not do that right now. Okay, so we've set it to be lumber sales. So we're trying to be all conservative like. So why don't you run your model out and see what happens? Uh-oh, we've just wiped out our forest. At this point, trees are growing as fast as they can, and we're harvesting them as fast as they're growing, and there's no forest left. Sure, we're getting our 100 trees every year, but wow, that kind of sucks. Okay, so we still have 10 minutes, so let's get working on our worksheet, which will be to try and solve this sustainability problem. And